Hello friends, how are you? Welcome to my YouTube channel Enlightened Mind. So until now we had seen factorization of simple algebraic expressions where some terms could be taken common. Then we used four basic identities of a plus b whole square, which was written as a square plus b square plus 2ab, and then a minus b whole square, a square, which was written as a square minus 2ab plus b square, and then a square minus b square, which was written as the multiplication of a plus b and a minus b. And then there was a general expression which was x plus a and x plus b, which was written as x square plus a plus b into x plus ab for factorization. Okay, so either the last constant term of the algebraic quadratic equation was a perfect square, or the factors of the last term was the sum of the middle term of the function or the algebraic expression. I request to please refer to my previous videos on factorization for detail. Now we will see here that if neither of these happens, it means that last term is not a perfect square, or the factors of the last term cannot be written as the sum of the middle term. Then what and how these expressions would be solved? Okay, so we have a method for that kind of questions, which is called cross method. Though we will study or do some questions on the cross method. So in today's lecture we would also learn some cubic identities where the highest power of the expression is cube, okay, and solve some questions based on them, and then set an SOP, which is the standard operating procedure for solving factorization problem. So please stay tuned. So up till now we have seen that there were we had seen two identities, four identities basically, which was a plus b whole square, which was written as a square plus 2ab plus b square. Then there was another identity a minus b whole square, which was written as a square minus 2ab plus b square. Then there was another identity that was a square minus b square, which was written as a plus b and a minus b. And then there was a general expression which was x plus a when it's multiplied with x plus b could be written as x square plus a plus b into x plus a into b. And in the last lecture we have also seen what are the physical interpretation of these quantities. So here the highest power of the expression you can see is twice, means it is the general expression or the algebraic expression where the highest power of the equation is up to square. So whenever there is a square term, it means that it represents an area. Likewise, if the highest term of an algebraic expression is thrice or the cubic term, then it represents a volume. Okay. So I already had written some of the identities. So you can see here identity second and third. These are the cubic identities. So we will do some questions on these identities, and this can also be written like this. So if you want to calculate a cube plus b cube, so that can also be written here in the fourth identity, okay, and then this one. So that is basically the rearrangement of second and third, okay. And then if suppose there are three terms of the cubic expression, so that is the last identity I have written here, and it can be extended up to power 4, 5 and so on, but we are not interested right now. So we will see these identities and we'll do some questions on that. And there was an expression for the quadratic equation, but here the term is 3, a, b and c. It's not limited up to a plus b, but a plus b plus c. If it is square, so that can be extended up to this. In the last lecture I also have seen the physical interpretation of the first quantity here, a plus b plus c whole square. So let us do some questions, but before that we will do some questions of crisscross method and how it is used, and when this particular crisscross method could be used. We will do some questions and then we'll try to understand how it has to be done. Okay, so suppose I have an identity. This basically we use the same kind of identity, but here in the cross method, let us take an example. So suppose there is a question which is 3x square minus 19 of x plus 6. Okay, so you can see here is, first of all, nothing can come out. कोई भी ऐसी कोई there is no term here in the expression that could be taken common, so it will remain as it is. Second thing, there is no perfect square, and this 6 cannot be factorized to write in terms of the sum of the middle term. Okay, it means whatever we have done up to now is not applicable here. So how can we do it this one? So what you have to do here is, just you have to check what is the multiplication of the first term and the last term. So coefficient of x square here is 3 and the last term here is 6. If you multiply that becomes 18. Okay, and then you have to see whether the middle term can be written as the sum of the factor of this 18. Okay, that you have to see. So you can see that factor of 18 are many. So one of the factor is 18 into 1. Okay, so that is the multiplication. If you write 18 into 1, that become 18. But then you have to write in terms of plus, so that you should have a negative sign and the sum should be minus 19. So if you write 18 plus 1, that is 19, but that is not minus 19. That is minus 19 is only possible when 18 is minus, okay, and 1 is also minus. So that become minus 18 minus 1, which is minus 19. Okay, so the first term here in case of multiplication would be 18 into minus 1. Okay, so that become plus 18. Minus 1 is multiplied, become plus. So the factors now is minus 18 and minus 1. So this can be written as, means this 3x square minus 19x plus 6. You have to split this middle term, but in the form of these factors. 18 minus, so two factors basically is minus 18 and minus 1. We have seen this from here. Okay, so this 19 can be written as minus 18 and minus 1. So 3x square would remain as it is. So minus 19 can be written as minus 18, and there is x, and then minus 1 of x plus 6. Okay, so that can be written as 3 into. Now you can take common out of these. So x is common, 3 is common, so you can take 3 and x common, so that become 1x minus 6. Here you can take minus 1 common, so that become x minus 6. Okay, so now x minus 6 can be taken as common, so that become 3x minus 1. So that is the factorization of this. So that method is called the criss-cross method or the cross method, because we multiply the last term and the coefficient of the first term. Okay, so let us do the next question. Suppose the next question is the following: 4 into x square minus x minus 3. So here the last term and the first term is 4 into 3, that become 12, and that basically is minus 3 basically. So you can write here is 4 into minus 3, so that become 12. Okay, and there is minus 12. So that is the multiplication. But if you multiply 4 with minus 3, that become minus 12. But what is the plus sign? So if you add this 4 with minus 3, that become plus 1. But we are not interested in the 1. We should have a minus 1 and in the middle. Okay, so that should be positive and 4 should be negative, right? So by that logic, so here 3 should be plus and 4 should be negative. If you multiply, that would be minus 12, and if you sum minus 4 and plus 3, so that become minus 1. Okay, so that is satisfying. So middle term should be written as the sum of these two terms, and we should get minus 1. Okay, and we are getting it. So the middle, the two terms should be minus 4 and plus 3. Okay, so now 4x square minus 1x minus 3 can be written like this. So 4 into x square, then minus 1x can be written minus 4x plus 3x minus 3. Now you can take common. So out of these only 4 and x is you can take common, so x minus 1 would remain, and here if you take 3 common, so x minus 1 would come out. So x minus 1 can be taken out common as, so 4x minus plus 3 would remain here. Okay, so likewise these expression can be solved. Okay, so let us do some questions the higher power. So I'm taking some question where the expressions have or could be solved with the help of some higher powers. Okay, so let us take this example, x power 3 minus 27. Okay, so I have a expression for term like this. We know that x minus or a minus b power 3 is basically a cube minus b cube minus 3ab a minus b, or this could be written as a cube minus b cube minus 3a square b, and that becomes plus 3a b square, right? Okay, but we are interested in this, so you can take here this common. So a cube minus b cube would be a minus b whole cube, and if you take this here, so that minus 3 would become plus 3 ab a minus b. Now a minus b can be taken as common, so that would be a minus b whole square plus 3ab. So when you expand this and add 3ab, so I will get a minus b a square, okay, plus ab plus b square. So that is the final expression. So basically I will use this identity 3 cube minus b cube is equal to a minus b a square plus ab plus b square. Okay, so let us apply this here. So now this 27 can be written as 3 into 3 into 3. Okay, 3 3 are 9, 9 3 are 27. So basically that can be written x power 3 minus 3's power 3. And if I'll take this as a and this as b, x here is I have taken as a and 3 as b. So this expression was a minus b a square plus ab plus b square. Okay, so I can write here a in place of a there is x, in place of b there is 3, and then a square, which was a was x, so x square, plus ab, a is x and b is 3, 3a 3x. Okay, and then b square, so b was 3, so b square means 3 square, that would be 3 into 3. Okay, b square, which is 3 into 3 square, which is 3 into 3, would be 9. So here you can take right 9. So x cube minus 27 could be written as this one. Okay, let us take another example. 5 into x to the power 3 minus 40 y power 3. Okay, so here you can take common. If you take 5 common, okay, so that become x power 3, and here it is 8 into y power 3. Okay, and 8 can be written as 2 into 2 into 2, so that basically could be written as 5 into x power 3 minus 2 into y power whole 3. So if suppose x is taken as a and 2y taken as b, so that would become a cube minus b cube, and a cube minus b cube could be written as a minus b, you already know it, a square plus ab plus b square. So now again you just put these values here in place of a and b. So here a is x, b here is 2y, then a is x, so x square plus ab, a is x and here is 2, so 2y to xy, and plus b square, which is 2y square, so that will become 4 into y square. Okay, so that is the full expression. Okay, now let us take another example. 64 into y4 plus y. So you can see here that only y could be taken as common, so that becomes 64 into y3 plus 1, because y you have taken common here. So 4 4 ja 16, 16 4 ja 64. So here 64 could be written as 4's power 3, and that is y power 3, so 4 into y power 3 and plus 1. 1 can be written as 1 power 3, because 1 power 3 is 1 into 1 into 1, so that would be 1 only. Okay, so 1 can be written as 1 power 3. So now again you take 4y as a and 1 as b, so a cube plus b cube. Okay, and formula for this is basically a plus b, a square minus ab plus b square. We already have written that formula, so you can see here this formula. So now you just replace a with 4y and b with 1. So a is with 4y, so 4y plus 1, and it is 16y square minus 4y into 1, so that is 4y, and b is 1, so 1 is 1. Okay, so that is the answer. So answer is y into 4 into y plus 1, 16y square minus 4y plus 1. Okay, so that's the answer. So likewise questions can be done. Okay, very easily. So let us now discuss some of the operating procedures when we solve any of the questions. And because whenever a particular question would come, we don't know what quantity would, what kind of formula would be used. It can be a quadratic equation, it can be a cubic equation. Okay, so we should have a standard set procedure which always should be used, and the question could be done on the basis of that SOP, which is the standard operating procedure. So let us set, and then we try to understand. So friends, the steps which we have to follow when doing the factorization is that we should take common terms out of the expression if possible. Okay, so if any terms like 5, 1, 2, 3 or any of the constant terms can be taken, you have to take that common, or x, y, z is everywhere, okay, in all the terms, so you can take that particular term common out of that expression. Second is, if the remaining expression suppose is quadratic, okay, so just you have to see the last constant term, and if that last constant term is a perfect square, then you can use any of these three equations. Okay, that we also have done some question in the previous lectures. It can also be possible that the last term is not a perfect square, then you can use this expression. Okay, and in the beginning of this very lecture we have discussed about the crisscross method, by which you can factorize a particular quadratic equation. Okay, and suppose the remaining term is not a quadratic equation, whether it is a cubic equation or it may be a higher term, so then we can use the formula accordingly. We have discussed some of the expressions like cubic expressions like a plus b whole cube. Okay, and that was written as a cube plus b cube plus 3ab into a plus b. We have seen this. So if suppose equation is in this term, so that can be replaced with this. Okay, and then if suppose nothing work, it means the there may be chances that the expression you are trying to factorize is basically the irreducible term. Okay, so it may be possible that that would remain as it is. Okay, so we have to follow this method while doing any factorization problem, right? So now we will see some of the questions, some practice problems, and there are answers also given. So just you can see and pause the video to see those questions. Try yourself to do all the questions. So that is the first sheet I am showing. So in that sheet there is questions from 1 to year 40, and you can pause the video and then you can solve the question yourself, and there are answers given. So I am just sharing that answer also. Okay, so you can see that there are answers given from 1 to 40, 30, and then I'll show the another answers. Okay, so just by seeing it you can do these questions. So let us see the second sheet. So that is the sheet having questions from 41 to 80. So you can solve these, and then these are the answers. Okay, now let us see the next one. Here the questions are from 81 to 120, so you can do these questions also, and there are these are the answers. So you can do yourself, okay, and if you find any difficulty you can please comment below the lecture, and then we can find the answer for that also. So if anybody has any problem, they can tell, so a separate video could also be made for the answers of these questions. So I hope the lecture would benefit many of the people. I request everybody to please share this video to your colleagues and friends, so that they would also be benefited. And if you like the video, please click on the like button and subscribe my channel. Thank you.